Yes, welcome to GCP Online Meetup number 36. I'm your host, Jonathan Cham. What's up, Antonio?
What's up, man? How are you?
Good. Thanks for
Yeah.
taking the time to do this. You're one of the rock stars here on the customer engineering team, and I think today you're going to talk about Spanner.
I am. Yeah.
Why do you like Spanner so much? I mean,
love
you love Spanner.
I do.
That's all you talk about.
I do. Literally, it's like, oh, we have a SQL. No, Spanner. Use Spanner.
Spanner for everything.
No. I love Spanner. So the running joke is like, as a customer. So I used to be a customer of Google, and I use Spanner as a customer. And it really cool. So the concept is that you get like SQL-like semantics. You get joins and relations and all of that stuff, and it works a lot like MySQL or Postgres. You have databases and tables, and the really cool part is that so there's a couple of cool things. The way that transactions work within Spanner and give you sort of a globally consistent view, and now the global replication, which we've also had out, right? So you get globally consistent, horizontally scalable relational database that is always correct, in the sense that your data that you're looking at is always going to be the most current view. It's not eventually consistent in that sense.
And it's completely managed.
There's no setup. There's no managing the service or running servers. You just push a button and you get a server.
Cool.
Yeah,
that's great. Yeah, I know you talk about all the great things about Spanner. Topic of this session is counting sheep, right? So what are we counting? Like, what's the big deal about counting, and why is it so difficult to count maybe in a distributed setting?
So it's funny because one of the hardest problems to solve for computing is keeping counters in a distributed fashion. So and it literally is exactly what it sounds like, counting 1, 2, 3, 4, 5, 6, 7, just incrementing or going backwards, counting down.
And in a single node, it seems stupid silly. Like, it's obvious, right?
You can just put Redis on there and just start counting up or counting down, or do it in memory in your code. But when you start doing that across 100 machines, or even just 2 machines, but you start doing that across 100 machines, it becomes much more difficult. Who wins? Who did it first?
Right.
What number are you incrementing? Like, there's a lot of things. And you can still do that in the sense of like, okay, you can launch a single Redis server, but now what happens when you have so much traffic that Redis server can't handle it? Well, how do you distribute that? So like, there's a lot of problems around some things like that, like counting and problems like that. So Sheep is actually an open source project that I created and I maintain on GitHub, and it's backed by Spanner. And it uses this sort of guarantees that Spanner have to guarantee accurate counts for your counters. So it's basically just a web service that's layered on top of Spanner that lets you sort of increment and decrement counters, arbitrary counters. They can be whatever you want, and it will always be 100% consistent every time, which is a really neat feature, right? So it's really cool. And it has different modes. You can be like externally serializable. There's all kinds of different stuff that you can do with it. But it works really well for things like how many likes does something have, or counting how many times an event has passed, where you absolutely need the perfect exact thing. Really good for gamification.
Right.
So like if you're gamifying stats or something, and like that matters, right? Like high score keeping and stuff like that, that can matter from that sense. So.
Yeah, that's great. I know you were going to show us a little bit kind of the interface for deploying Spanner. Maybe we'll go into a little bit of the code. Anything you want to talk about before we jump right in?
No, I mean, I think that it's going to be pretty self-explanatory. We're going to go over, how to actually set up Spanner in the UI.
Right.
Obviously when you're doing this at scale, you'll use something like Terraform.
Yes.
Which I also did a talk on.
Yes, we'll link that, Terraform.
But you'll use different stuff to sort of do it. But we'll go through the UI and I'll sort of show like how this goes. So let me go ahead and
Why don't you share your screen real quick?
Let's
so while you guys are listening, feel free to ask a lot of questions. That's why we're here. Hit subscribe if you actually hit subscribe either way. If you like or don't like the material, we'll make sure we'll improve it if you don't like it. But I know so far we've got a lot of good feedback about the content that we've put together. So looks like, Antonio, you are ready to share. Let's take a look at what you got.
All right. So we're going to go through here and we're going to create an instance. This is on the Google Cloud platform UI. So for the purposes of this demo, we're just going to make something called sheep test. So initially, when you select your Spanner instance, you can either select regional, so your data lives in one location, or you have multi-regional configuration as well. This is important to sort of note and just kind of read the side if you want to do multi-regional or regional. And there's different configuration options with more, coming along the line at some point. For the purpose of this demo, we're going to go ahead and we're just going to do single region. So the number of nodes here is kind of important to really understand. It gives you the idea of parallel operations. So if you have lots of rows or lots of things, Spanner will automatically sort of partition your data and sort of distribute it out, find hotspots as you're using it. It sort of learns your pattern and your behavior for how you're using your database, and it'll start distributing data across however many nodes. So if you have 30 Spanner nodes and you're really hammering this one little specific data set for whatever reason, this range of rows, Spanner will detect that and sort of split that out and kind of chunk it up into as many pieces as it needs to, up to 30 nodes. So now you're hitting 30 nodes behind the scenes instead of just overloading one node. And you don't have to do that. That's all magical, like the
it's all
magic.
managed. Yeah. Okay. And one thing I actually found out recently was there's a linear improvement as you add more nodes.
Correct.
There's no kind of diminishing returns as you add more nodes. You get just the same amount of improvement.
Yeah.
I think tens of thousands of queries per second for each node or something.
Yeah, there's a node guidance that you can go through here. Yeah,
10,000. Okay.
So about 10,000 QPS of reading and 2,000 QPS of writes per node. And that's a linear increase. There's no diminishing returns when you do that. So
that's great, and that's because we separate the storage and compute, and that's kind of just how we've developed and designed our infrastructure here at Google.
Yeah, that's exactly right. So our whole concept of how we do everything is that we have the storage layer, and then you have the compute layer, right? And the storage layer is elastic by itself, and then the compute layer is elastic by itself. So we can reshuffle like storage data, behind the scenes, and then reshuffle compute data behind the scenes in two different ways. So we can scale where we need to instead of sort of having like, okay, you need to have this much compute and this much storage, and it's tied one to one. That ends up being cheaper for the customer as well. So there's a better price point by doing that.
Yeah,
so,
yeah.
So I'm going to go ahead. We'll create this instance of Spanner, and
so while it's creating, it's basically spinning up some instances underneath, setting up all the software, and
it's already done. So it's actually pretty quick. It doesn't take very long at all. Usually a couple of seconds.
That was really fast.
Yeah. So it's pretty fast behind the scene. We do our magic, and you just have an instance, and you have a single endpoint that you hit via the APIs. So you have several languages and APIs that you can sort of interface with. And here you can see that it works a lot like SQL. So you create a database, blah, 1, 2, 3, and then you can define what the table looks like. So you create database, table, and then the schema for that table, right? So
it's very SQL-like.
It's pretty much exactly like you would imagine out of SQL. So I'm not actually going to create something through UI. We're going to do this programmatically.
Perfect.
So we'll show some of the programmatic stuff in a bit. So I'm going to switch gears a little bit, and we're going to look. I'm going to do some very, very light touch code. I don't want to get too technical, but I do want to sort of show where the magic comes in and why this is just like, oh, wow, this is really cool kind of thing. So I'm going to go ahead and switch over to my code editor. This is all in Golang. So all of you gophers out there.
There you go.
So we're going to do is we have a Spanner client, and we're opening a read-write transaction. That means that we're calling a function here called doSave, where my cursor is, and everything inside of this function is within a Spanner transaction. And within this function, you can do anything that Golang can do. So you can call out to Elasticsearch. You can call out to another database. You can do anything that would require that kind of work.
And just to step back for a second, I mean, there are libraries, the Spanner libraries in Go. Okay, so people would just import the library.
Yeah, you just import the library that we provide for you. Perfect. So where the magic comes in is within a transaction, you can read a row. So in this case, we're reading a row for how sheep works. And what Spanner guarantees that within this view of the transaction, this row, when you work or modify on this value, it's never going to change out from underneath you. So there's never going to be some sort of contention where you read a row, you make a modification, you write it, but it was written by somebody else while you were doing that. That can never ever happen within Spanner. It either works in a linear way from your perspective, or the transaction fails. And then either the client will retry it until it succeeds up to a certain amount of time, and then it throws you an error if it doesn't succeed, right? So that's kind of where that magic comes in, and that sort of gives you this guarantee. And the really interesting part is that this works regardless of how many spanner nodes you have, right? So you can have hundreds of spanner nodes, and it doesn't matter. You are guaranteed, no matter which node you're hitting, no matter where in the world you're hitting, no matter which replica you're hitting, no matter what it is, you're guaranteed that you're going to have a linear history, externally serializable linear history of your transactions. So top to bottom, everything that you do is guaranteed to be how you would imagine it if it were just locally, like if you were just doing things locally.
Right.
Which is really, really neat.
Yeah. There's a lot of magic going on. Can you describe, like, I think a lot of people don't understand the complexities when it comes to so many distributed nodes and trying to basically have consistent communication between all of the nodes. Like, what would you have to do without Spanner to take care of all of this? Like, I mean, you know, like you talked about locking, right? Making sure that you lock.
Right.
What are all these other things that you need to deal with if you weren't using Spanner?
So you would have to deal with a couple of different things, right? So one, you could lock, and people, one of the common things that we hear is like, okay, well, how is this different from Postgres? You can lock in Postgres, or you can lock in MySQL,
right?
Sure, but you can lock on one server. What do you do when you have way more traffic than you would need to? Than one server can handle, and how do you lock across data that's distributed across a bunch of nodes? And now you're like, okay, you could use an external locking system. Okay, well, how does this locking system, now that you're running like a distributed locking system of some kind, how do you make sure that they're consistent, that they don't collide, because they're running on several nodes, right? You're not going to have just one little single point of failure locking system. Well, you have to check with timestamps, like whichever one hits first, and you make sure and you reconcile two-phase commits, all of this like heavy database sort of language.
And this is on the onus of the developer.
This is you have to manage that infrastructure. You would have to like figure out and do all of the complex logic, and that is not an easy problem to solve at all. Like,
absolutely.
To this day, there are people who create database systems, and then when you put them under load or you put them through test, you realize, oh, this is not as advertised.
Yeah, like I'm spending all my time figuring out how to make sure I'm locking all these other nodes before I do my transaction. But with Spanner, I guess what we're doing is the developer can just focus on what he needs to accomplish, what he or she needs to accomplish, and not worry about the locking.
Yeah, that's exactly right. Yeah, and then when I was writing this, the first time I started using Spanner earlier this year, I sat here and I wrote this code, and in my mind, I'm like, oh, this isn't going to work. This isn't going to work. This is crazy. This isn't supposed to work. Yeah. What am I doing? And then you run it and you're like, whoa,
it worked.
It just works.
Yeah.
You don't have to think about it. So it was definitely a surreal kind of moment for me in terms of how this works. So essentially, going back to specifically what Sheep does, Sheep keeps a transaction log. And what it does is it checks and makes sure that every counter, every increment, every decrement that you do has a unique ID attached to it. And it makes sure that that unique ID is never actually incremented or decremented more than once. And we do that by reading the transaction log. Does the transaction exist? We return and we say, no, it already exists. Let's not do this transaction. If it doesn't, then we do our increment, we do our decrement, and we do our entire operation. And then we save at the same time, atomically, we save the new value of the counter and the actual transaction. So it either all succeeds or it doesn't succeed at all, right? And this is kind of like the Spanner magic in that. And from the terms of code, this can be, if you're not a programmer, this can be kind of difficult to understand. So I have a demo prepared.
Yeah. Oh, yes.
And this is a live demo, so fingers crossed that this is this will do what we need it to do. So we have a terminal here, and we are actually going to go ahead and start up Sheep here locally on my Mac, and here we're ready to go. And one thing I want to note is that Sheep will go ahead and actually create all of the database and the tables for you. So you can see here the schema for each table, stats, and then transaction table as well. So now we're going to go ahead and run a quick little demo.
Nice.
Fingers crossed.
Yes.
All
so
right.
What's the demo doing?
So the demo is essentially going to take a counter and it's going to calculate a certain set of steps, a certain set of operations, like add the number 10, add 10 times, subtract 5 times, add 20 times.
And different nodes are doing this.
And different, so what's going to happen is this one laptop is going to do it, but it's going to do it threaded. So it's going to do it in parallel across multiple threads in the background. So it's going to happen concurrently and in parallel across round. But what you're going to see is after all these submissions are done, you're guaranteed that it's going to be 100% consistent, right? Okay. So you're going to see that the output should be this, and then we're going to do a curl against the local API, and the response back that you're getting at is the exact calculation that we've predetermined what it should be.
Great.
So this is actually pretty quick. We'll do make demo, kicking it off, and done. Cool. So to go over the output here, we did 67 operations. That's 67 HTTP calls that we have done. And by the end of it, we should be at the number 9 for the test counter.
Got it.
And so what we did was we added 7 times. So we made 7 HTTP calls to increment. We took away 7. So we did 7 decrement calls. It should have been at 0. Then we decremented by 4. Then we did add 9, 6, 3, 8, and we ended up with the number 9. So now if we do a curl, we have ended up with value number 9.
Cool.
So we are guaranteed every time that, and we can run it again and it sort of wipes it out and does it another time. -6 is the number that we will end up with. -6.
Nice.
That's right. And we can do that across 10,000 threads and hundreds of machines, which I actually have done. So this is actually a service that I built internally for this massive 30 million user platform. And it always
you've tested it on that. That's great.
Battle tested. So
that's amazing.
That's the concept of sort of this distributed system. So
and you wrote this code. It's open source. We'll post the GitHub on the description. What is how do people use it, or how would you encourage people to use it? And what are the reasons why people would use your specific open source project?
Specifically, if you want to keep counters for things that are important, where things like hyperlog log and stats aren't good enough. If you need to keep counters for operational means, not necessarily for statistical means, but for things like a counter in a user profile, right? Specific number of times somebody has taken some action or some action has happened, where you need the exact number without any fudging because there's ranking, for example.
Right.
Those are really, really good use cases for this. Again, because this is a service that you can sort of just launch in Kubernetes, for example, or even App Engine or whatever else. You don't need to worry about your driver, it's just HTTP calls. So you can just make HTTP calls against the service to increment, decrement, and get values in a perfectly consistent way. So
okay, very cool. We do have a question about kind of moving. What is the migration path to Spanner? Whether it's from a relational, like a SQL, or even a non-SQL, is there? What is your suggestion?
So my suggestion, I'm gonna actually stop sharing the screen here so we can
just talk.
Yeah, kind of just talk here at this point. So that's a great question, and that's one that you face common in all infrastructure, not just with Spanner, right? Like, how do you migrate from database A to database B? And that is, there's no good one answer, right? There's no one magic bullet that'll just kind of do it for you,
right?
Regardless of the database that you use. Generally, I always hesitate. My default answer is that you do it at the application layer. So you start dual writing your records to both your whatever old database that you're using, whatever other database you're using, and Spanner. Start dual writing, and then when you have the dual writing, from that point in time, do a dump of your other database, and then read those records in and insert them into Spanner, right?
Yeah.
So, and then make sure you have to rewrite your query logic and make sure that everything works. But that's always something I encourage to happen at the application layer,
right?
Instead of trying to find some magic thing that will just do it for you. It's always better to custom tailor stuff like that.
Right. And then you probably would, if you need the old data, you would maybe find a way to export it into. That's probably something we could probably improve on, is building out more of these tools to help you. Export or kind of transition over to tools.
I think it would be cool to sort of explore tools where we can say okay, this MySQL thing, we can sort of just translate it into Spanner, right? Like copy that data, and copy the appropriate type. So
right. There's another question about what is the sweet spot use case for Spanner?
Sweet spot use case.
I mean, financial is always a big one I hear about.
Financials are a good one.
Mhm.
I'm working currently with someone who has a very big sort of like a follower slash like abstractions. So they have users and then things that they are following kind of thing. And this has become when you reach like a certain scaling point and you're using something like Postgres or MySQL, you need to shard. You can figure out how you're going to shard, and that becomes difficult, right? So they wrote this sort of complex logic to do it, and it works, but it's like thousands of lines of code that they want to get rid of, right? So I'd say that the sweet spot is that if you need relational SQL-like
global consistency,
anything like that. If you need any of that, even if you don't need necessarily the global consistency, but you just need relational sort of SQL-like semantics, and you need to scale to a certain point, then Spanner is already a good use case. The consistency and all that is just sugar on top. At that point. So.
Okay. Yeah, that makes sense. And then this is similar. I mean, we kind of talked about this, but is the use case for Spanner more relational or non-relational?
So that's actually a very interesting question. There's really nothing that stops you from using a relational database as a document store, right?
Right.
You're just getting and citing records. And I would actually argue that that is probably the majority of the use case of most relational databases. That's why document stores had this like huge boom, like the NoSQL movement, was because it turns out most people weren't doing joins, they were just getting and setting.
Right.
So why would you have like this relational database with all the stuff that you don't use? And that's where that sort of like boom came forward.
Yeah.
So you can, that's certainly a possibility to use it in a sort of non-relational way. But the cool thing is that if you ever need to like, darn, I really do need to join.
Yeah.
It's there.
Yeah.
You can do it.
Got it. I'm going to put you on the spot here. I know you love Spanner, but when do you not use Spanner? Like, when is Spanner not a good use case? And let's take out the costs, because we know Spanner is a little bit, you pay a premium for that kind of global availability and consistency and all of that good stuff. But
when you are absolutely 100% sure that you will never need transaction global consistency or relations, then it's not that Spanner isn't a good use case, it's that you don't need Spanner,
you don't need it.
Right? You don't need it. At that point, you can use data store. You can use any number of other things.
Just like a Cloud SQL.
Like a Cloud SQL even, right? So the other not good use case is monotonically increasing rows and IDs. So timestamps, time series data.
That's where Bigtable would come in.
Ding, ding. Yeah. So Bigtable is what you really want to be using for things like rows with monotonically increasing timestamps on them, or row prefixes, right? So key prefixes on the row, things like that. Things where your data is just structured into columns, and you really just need like very, very wide millions of columns type of thing, right? That's another good use case for Bigtable, and not a good use case for Spanner.
Got it. Very good. And then, do you know anything about the read-write latency? Would it be a good app of choice for fast queries?
Yes. So Spanner is an operational database. It is not an analytics database. It is meant to be in line with your user's interaction. So you would use it in the place where you would use MySQL or you would use Postgres. It's usually millisecond E, single digit millisecond E response time. So, and you can see that some of these queries are usually around 2 to 3 milliseconds for just a simple get on just selecting like star, for example, right? So that's very simple. And even simple filters or simple queries or simple joins, they're very, very quick. That's the whole thing, is that it's an operational database.
And I guess, depending on whether you're deploying, I guess, do the number of nodes add to that latency? Because would you have to replicate that? I mean, is that a factor that you take into account?
It is. So actually, so one of the things that you will see is that the larger the amount of nodes, there is an increase in latency over time, simply because you need to go out and compute across, and then you have to collate and filter and bring things together. Even then, you have to hit some pretty large numbers. You have to hit into the hundreds to get some pretty bad like latency, or some latency where you would actually notice, right? So at that point, that's where things like caching and understanding like how that works.
Yeah,
So,
yeah.
Which you should be caching anyway, right? Like there should always be a caching layer in front of your database, even if it is
Exactly.
So
exactly.
those are things that you can take into consideration as well.
Yeah, and I think, I mean, one of the benefits of running on Google Cloud Platform is our network, right? So because of our really fast network, yes, there's going to be a little bit of latency, but not as much as maybe, you know, where if you were going to run it on another cloud platform.
Right.
So, you know, customers have kind of appreciate, you know, how fast our network is. And that's just because we run all our, you know, Google stuff on there.
Yeah.
Gmail, calendar, maps.
Yeah. The still secret sauce of like how networking works here is pretty amazing. So
yeah. So that's good. And I see Alex is, can you talk about the pricing model as well? I think it's just per node.
I believe so. Yeah. Okay. So it's really just.
We're not pricing guys, by the way.
Yeah, we're not. We're totally not. We are gigantic engineering nerds. We are not pricing people.
Yeah.
But the cost per is storage cost and node cost.
Okay. Storage cost and node
cost. So you pay a flat rate per hour for the amount of nodes, and then you per gigabyte you are paid per gigabyte for the amount of storage.
Right.
And that depends on the region that you're in. So for example, in Central, our sort of biggest region, it's 30 cents per gigabyte a month, and 90 cents per hour.
Got it.
Per node.
Great. So. There you go, Michael. These are good questions. And then, yeah, I mean, you know, Alex is actually providing, one of the viewers, is providing some information about research blogs. So yeah, I mean, there's actually been some pretty good blog posts, public blog posts about their use of Spanner, why they're using it. We'll also post that as well.
Yeah, definitely.
Yeah, so let's see. I think there was a good amount of questions. I think that's kind of it. And you are way under time, which is awesome.
All right.
Yes. So I think our next steps, I'm going to put your GitHub on there.
Yeah, definitely.
We'll put maybe a couple of blog posts of other customers using Spanner. Was there anything else that we had to do?
I think that's it. You know, there's just use it. Give it a shot, guys.
Give it a shot.
That's like the key thing. I think that you'll be pleasantly surprised, especially if you're a developer, especially if you're a programmer, and you start like diving deep into transaction world. It's pretty amazing.
Yeah,
all the way through.
And every new user gets like $300 or something. So there's really no excuse not to play around with it.
Yeah, definitely.
So yeah, we'll stick around for. Oh, did you guys talk about the language different from SQL? Okay, so how is it different from SQL?
So it's SQL-like. It doesn't have 100% sort of ANSI SQL compatibility, but it's something that we're sort of augmenting and working on as time goes on. It's so you can't just grab your query and port it over. Kind of. So there are some queries that you actually can, but there's some things that you kind of need to look and kind of understand how, you know, what's missing from the language or what isn't there, right? So.
Okay. No, that's good. Thanks for that. All right. Well, Antonio and I will stick around for a couple minutes. We'll probably go on mute for a little bit and wait for you guys to ask some more questions. But thank you so much for joining, and hit subscribe. We're coming out with a lot more material next. I think next week we're doing Chromebooks.
Oh, awesome.
Yeah, it's kind of a different one.
Yeah, it's going to be different.
Kiosks or Chromebook kiosks.
Oh, cool.
Yeah. And then the week after that we'll do Kaggle, machine learning.
Yeah. That'll be fun.
It'll be pretty interesting. But I know we're definitely going to have you back because you're doing a lot of really interesting things all the time.
Yeah, I've got some pretty interesting stuff.
Oh, yeah?
I want to go over that.
Okay.
We're excited. Can't talk about it.
Kind
of secret. But definitely when it's public, I definitely want to
Okay, awesome. Yeah. We're excited. Yeah. Thank you so much, Antonio.
Yeah, of course.